welcome to the session in which we would like to introduce a proof of concept that we worked on that had very demanding machine learning requirements. My name is Andreas Forster. I'm a data scientist at SAP, working in the Global Center of Excellence for Data Analysis. And the proof of concept we did was together with my colleague Stoyan, who is also presenting here today.
Hello from my side. My name is Stoyan Maleśliński. I'm also a data scientist, a part of the Global Center of Excellence in Platform and Technology Data Value team. And I'm happy to co-present with Andreas today on this exciting topic. Back to you, Andreas.
Super, thank you very much. So let's see what we do in the next 20 minutes. First of all, we will introduce you to the use case that we worked on, as well as the platform that we use to address that use case, SAP Data Intelligence. And then we have two demonstrations prepared for you. First, to set the context, where we show how to train a machine learning model and how to use that model as a real-time scoring equation. And then in the second part, we will show how to deploy that construct as part of a real-time Kafka pipeline. Now, the use case that we worked on, this was together with an operator of passenger trains, a company that wants to optimize its marketing campaigns and messaging. No matter where you are, whether you're logged onto the website, whether you're on the app, the messaging should be personalized. That company has millions of registered customers and detailed history about these customers saved in an SAP HANA environment. And in order now to tailor the communication towards the customer, specifically when the person is on the website, the requirement is to be extremely fast, because now predictions should drive the content of the website. While the person is on the website, the prediction should be available within 50 milliseconds, but also depending on how many people are logged onto the website at the moment, it might require 2,000 predictions per minute. And if you want to promote 50 different products or messages, you require 50 different machine learning models. Training these on a monthly level means you need to train 600 models per year. So a highly automated approach is needed. And looking at the architecture that we worked with, now here, starting at the bottom, first we have data in the HANA system where we also have the machine learning algorithms. That data is now used through data intelligence where the model training is triggered. And that is the first part, the training aspect of the machine learning project. And the second step, the scoring, I show from top to bottom, where the customer already has an online content management system that drives the content of the website, that knows which customer is currently logged on. And this system is also sending Kafka messages about the people that are logged on with the ID of that customer. And now data intelligence is listening to that Kafka message, taking that information, taking the customer ID, enriching it with additional context about these customers, and then creating a prediction, which is then fed back to Kafka, which is then used by the content management system. And so the scope of the project was listening to Kafka, creating the predictions, feeding it back to Kafka for the content management system then to leverage that information. And the platform that we're using, SAP Data Intelligence, really our platform for data governance, data orchestration. And here we focus particularly on the intelligent processing. Inside that intelligent processing, you have what you need to create machine learning models in a HANA environment, to deploy these models into production. You're able to connect to the data sources, to explore what is inside these data sources, to prepare the data. If you're a data scientist, you may want to freely script in Python. So we've doing the notebook integration to explore with machine learning models. And once you know what exactly you would like to deploy, you can bring it into these graphical pipelines for the operationalization. So that brings us to the first demonstration where we want to show the context. And here we focus on the training aspect, where I will show how out of data intelligence you can use a Jupyter notebook, where through Python you connect to HANA, you train the model in HANA using the automated predictive library, a highly automated approach, very lean, no data extraction needed. And once that model is available, I'll show how to turn that into a JavaScript scoring function that you can use for real-time scoring. We run a quick test to see how that performs. So at that part, we could show the first demo video. Let me start by opening the launchpad of SAP Data Intelligence. And of course, we cannot show any customer data here. So we've brought a sample data set along data from a bank that has existing customers who they want to sell an additional product to. The data now in this example is stored in HANA Cloud environment, to which we have a central connection defined in the connection management. And this connection's name we will see multiple times in this demonstration, My HANA Cloud. But this implementation would work just exactly the same with a more conventional HANA on-premise environment. So we have that central connection, and I'm ready to start the machine learning project. And the project is held here in the machine learning scenario manager. We have already multiple projects here, and we are working in this Kafka project. So opening this project, we can see the different artifacts that are needed for a machine learning project, started by data sets that you can register, but you don't have to. We have notebooks where you can freely script in Python, whether it is to explore the data that you are working with, or whether it is trying out different options for the machine learning. Once you know what exactly you would like to deploy, you can go into the graphical pipelining, and the remaining tabs keep track of the pipelines that have been deployed, that were run, and the objects that were produced by these pipelines, such as trained machine learning models. And now I would begin by looking at the data that we're working with. So I'm opening a notebook. And this notebook, we're using a library that we have released, HANA-ML, which allows us to connect to HANA Cloud or HANA on-premise, where with this connection, the data can stay in HANA, but the calculation still happens in HANA. So if I want to calculate how many records do I have, HANA will calculate it. If I want to train a machine learning model, HANA will calculate it with the algorithms HANA has, no data extraction needed. And just to briefly show an example, I'm using that library. I'm using the connection, My HANA Cloud, that we'd seen earlier. And I'd just like to show a few rows of data, the data on which the model will be trained. Each row is a person, an existing customer, about which we have a certain information, such as the age or the education, and the purchase column tells us whether this person bought the product or not the product that we want to promote here. And purely for time reasons, I won't be able to execute all the code, so I'm just scrolling through, showing you the most important aspects. And in here, for example, purely by executing this describe method, HANA is calculating a lot of information about the columns that we've just seen and about the content of these columns, such as what is the average value, what is the distribution of these columns, or how many null values, missing values do I have in each column. I can also ask HANA to aggregate the data, such as the target column, the column on which we want to predict. Here we can see that only 12% of the people bought the product, 88% didn't. You can have it as a table, or you have full flexibility with Python to visualize, and here with a simple bar chart. So we have a very first understanding of the data, and imagine we are ready to train a machine learning model. This here I put into a separate notebook, even though all this code could also be in the same notebook. I just found it helpful to separate out. And we're using the same library, HANA-ML. We're using the same connection here, the same data set, the same table that remains in HANA. And we're using this algorithm here from the automated predictive library, a highly automated approach, a lot more actually than a simple algorithm, where HANA on its own is finding the best model for this data set for the task that we're giving on our purchase column. And executing this code, HANA trains the model, gives us information about the model, such as the AUC value, area under the curve. You can visualize the model quality here with the receiver operating characteristics curve. And we can also look into the findings of the model. What is which column was most important for the prediction? The month, for example, was chosen to be one of the most important columns. And you can even look into the individual columns, how they contribute to the prediction. This chart now is showing the months in which we were most successful in our campaign on the left-hand side. So running this campaign in December, March, October, September, we were most successful because there might well be a business reason behind why these customers in those months were most likely to buy the product. So now we've trained the model and we can use it. We could use it directly in HANA. We could use it in graphical pipelines. But here we want to go one step further to achieve that scalability. And in this notebook now here, we see that the first steps are identical. The same library, the same connection, the same data set, the same model that is trained. But now the specialty comes in that the trained model, we were able to export into a JSON construct that contains the logic of the model. And with a very lightweight JavaScript runtime, we can now use this JSON syntax to score new records in real time on the fly. Showing a small example, this JavaScript file here is using that JSON file, and it's now scoring one exemplary customer, a customer that is 40 years old, that is an entrepreneur, and a customer that is married. And running this JavaScript code will give us that prediction. So going back to the notebook, I'm now calling that JavaScript file we just seen. I execute it, and it estimates for this person the prediction, the probability of being interested in that product is 23%. And this calculation took 60 milliseconds. Let me execute that again. We get exactly the same prediction, but now second time round, it only took 17 milliseconds. And this construct now, this JavaScript code, Stoyan will show us how we managed to implement that into a pipeline in data intelligence, listening to Kafka for scalability and performance.
Thank you, Andreas. Now with the second part of the demonstration, we're going to see how we actually deployed the model, which Andreas showed. In this part, we will be moving into the central part of the landscape, being the SAP Data Intelligence and the Kafka messaging server. And we're going to see how we realize the real-time scoring using Kafka messages. In the demo itself, we will simulate the simultaneous arrival of 1,000 customer IDs that will arrive through a Kafka message through the new data topic. And at the same time, we will be monitoring the output and how long it takes data intelligence to process this input, score the customers, and come back with the results. After that, we'll be looking into the scoring and the training pipelines to understand the details in there. And finally, we're going to simulate the arrival of a new message on the new model topic, and thus simulating basically a basic CI/CD pipeline. Let's see how it actually looks into the demo system.
We start off with the scenario manager of SAP Data Intelligence, and we jump into the scenario Purchasing Affinity Real-Time Scoring Kafka, where we have the training and applied pipelines, as well as a scoring pipeline with multiplicity applied. For the purpose of the demo, I will just now trigger the apply pipeline, and then we'll go into the details and see what it actually is made of. So I'll just follow the wizard through the steps. And run the pipeline. On the modeler side, I'm now switching to the modeler. We have seen that the pipeline is currently scheduled for execution. And if we look into the pipeline itself, we will see the following artifacts. And the heart of it, there's the Node.js operator, which contains the source code shown in the previous part. You can see here that it's loading the libraries, and then it's applying the model and writing the results into a debugging and the output ports of the operator. Now, as we can see, this Node.js operator has two inputs. One is the so-called data event, and this is this Kafka receiver. And the idea here is that it subscribes to the topic new data. And as soon as a new customer ID arrives, this is being forwarded to the Node.js application code. On the other hand, we have the second input, which is called the new model event, and it listens to the topic model maintenance. And as you can think of it, probably as soon as a new model name is applied, it also gets forwarded to the Node.js script. And there is logic in it. As soon as this model message arrives, the model is actually loaded into the current version of the provided version of the model is loaded. And it's used for scoring as soon as new data comes in. Now we can see the pipeline is running, so we can open the terminal. And we see already one debug message called loaded new model. And that's exactly the initial loading I did. So initially when I started the pipeline, I provided the name of the model, and that's where it actually went. Now, let me switch to another terminal window here, which is just an SSH connection to a Kafka server. And I can use the following syntax here, the shell script, to specify a broker as well as a topic. And as we know, the new data topic is the one which we can use, which our listeners are subscribed to for customer IDs. So I can provide a customer ID number 3, for example, and we'll see here in the background, the customer 3, this is the score of the prediction, and this is the execution time. And we can do a few more just to get an idea, how much time it takes. And at some point it will actually go down to 6-7 milliseconds, and it will stay at this range for a single one. Just for the sake of completeness, I want to show also if I use the model maintenance topic, I can also update my pipeline and provide the name of a model which it should load. I will take the same model name just for us to be on the aligned and not to add another model. And if I do that, purchasing affinity model JSON, we will get the debug information, new model has been loaded. Okay, so this was the first piece. And to do the ultimate test, I have another file which is called test customers. It contains 2,147 customer IDs, as you can see here. And what we can do is, following the same syntax as before, we can actually pipe all of them into the shell script, and all of them will be sent to the scoring operator. As you can see here in the background, now the scoring happens in real time, like live, and we can see that once it's finished, that it took roughly around 9 seconds to execute, right? 9.15. And you can see that the single execution is somewhere between 5 and 3, something around 4 or 5 milliseconds. Another interesting part which can be done is actually we can increase and scale even more, even though this was already extremely fast. I will execute the pipeline with the scoring, with the multiplicity, which adds one more dimension to the whole thing. So basically I will specify multiplicity of 5, provide again the model name, and I will start the pipeline. Just let me switch back to the scenario manager and stop this, our pipeline we just tested, and we wait for this one to get executed. The only difference is that now this Node.js is packaged in a group, and the group has a multiplicity of a parameter multiplicity, which was provided, as you can see here, and now it has 5. So basically 5 containers are started. So the pipeline is running. I will just again open its own terminal. And voila, we see that actually 5 load new model debug messages have been shown here. And this means exactly that during the initial loading, the model was loaded 5 times in the 5 different containers. And if we now go back to our previous experiment and send again the 4,147 customer IDs, we'll have 5 containers running in parallel, which means that we can process roughly around 5 customer IDs at a time in parallel. There's some offset, so the value wouldn't be just 1/5 of the value we had in the other one. So before we had 9 seconds, here we have 3.1 seconds for all those cases. And actually I can execute it one more time, just for to get an idea. And again, yeah, it's 3.1 seconds for the whole. And this is a great feature because, as you see, with only one parameter, we're able to actually scale pretty well. Now, I'll go back to the modeler, to the scenario manager, just to show you one last pipeline. This is the training pipeline. And the training pipeline was actually created using the HANA ML train template. And there's 2 slight modifications. One is that the HANA ML training operator actually now has one more output, which is called JSON. And it outputs, in addition to the blob version of the model, also a JSON version of the model. And this is stored in a different place in the artifact producer, basically the new model name underscore JSON. And there is a Kafka producer, which is a key part here, because now this sends a message to the topic model maintenance that the new model is available. And the idea obviously is, have a simple CI/CD process, continuous integration, continuous deployment, where training pipelines actively notify application pipelines or everybody who is interested that a new model is available, so those can react and update and use the new model if needed. The rest of the pipeline is exactly as it comes out from the template.
As a summary of what we saw in the previous demo, here on this slide, you can see the details. It's on one side the scoring pipeline, which runs continuously, and it's listening through a Kafka consumer operator to new data, being customer ID coming in. Then this pipeline processes this customer ID, applies the model, and sends the results, the prediction results, back to the CMS system. On the other hand, we have the training pipeline, which runs periodically depending on the dynamics of your process. And as soon as a new model is trained, it's safe in the model repository. And the exciting part is that it uses Kafka to notify any scoring pipeline which has registered on this topic that new model is available, thus making sure that the next time new data comes in, all scoring pipelines will actually be using the up-to-date, updated machine learning model. And now to you, Andreas.
Super. Thanks so much, Stoyan. Really impressive. And just to wrap it up, so what we've seen now, how we can deploy machine learning connected to Kafka. We can do that with high load requirements. You saw that 2,000 requests, so it took about 20 seconds. With low latency, and the demo what Stoyan showed was even 3 milliseconds per request. We can do that with uptime. No need to stop predicting to bring in a new machine learning model. It was all done very smoothly. It's also scalable on the machine learning aspect with the automated machine learning where the model was trained in the first place. And we managed to keep the architecture lean. The models were trained in HANA, no data extraction, no data duplication required. And that use case here now, we showed it around the marketing requirement, but it's so relevant for so many different use cases. At the end, it comes down to a classification. It has no prediction. And only to mention one example here, this could as well be a manufacturing quality prediction while manufacturing process is still ongoing. So we put down a few other TechEd sessions that we believe you might be interested in if you like the content of this session. We don't have time now to mention all of them, but you have access to the slides. Please download, please have a look. And you might also already have heard that as part of TechEd, you're given free access to the SAP Learning Hub, So please feel free, of course, to try it out. And with that, I hope you enjoyed the session. Many thanks for listening. If you have any questions, please reach out to us. Many thanks. Goodbye. you.